The Raga Community College is one of the HEIs affected by the pandemic brought by COVID-19. In its quest to continuously provide quality education, several programs and projects are instituted through the different offices of the college to adapt the challenges of the new normal. Synchronous and asynchronous platforms have been instituted since pandemic started last year. These flexible learning modalities became effective in the teaching and learning process of the students as manifested by the results of the feedbacks for the past academic year. This academic year, 2021 to 2022, this institution has come up with another strategy to further enhance the students' learning experiences. This school is introducing the program DCOMC e-ERe or DCOMC On Air. In this platform, lessons in different disciplines will be aired live via Facebook page of DCOMC every Tuesday and Thursday, 8 to 11 in the morning and 1 to 4 in the afternoon.
Good day everyone, I am Teacher Madeha and this is the first online broadcast of the project e-ERe of the Raga Community College. Today, we will be discussing about problem solving and problem solving heuristics. But what is a problem? According to George Polya, a question is considered a problem if the procedure or method of solution is not immediately known but requires one to apply creativity and previous knowledge in new and unfamiliar situations. He further said that to have a problem means to search consciously for some action appropriate to attain some clearly conceived but not immediately attainable aim. Clearly, the degree of challenge a question gives the student is what makes it a problem or not. It is considered a problem if the student may be able to identify what the problem is asking and the given data that is relevant, yet encounters difficulty on how to solve, that is, where to start or what series of actions to take. Now, on the other hand, what is a problem solving? Every person does problem solving every day. In plain language, problem solving is the ability to overcome or remove an obstacle so that we can get what we want. It is one of the main thrusts of mathematics in the K-12 curriculum. In fact, we can even assume that the whole aim of education is to equip children to solve problems. And that is also the main purpose of mathematics. And this and many more reasons make problem solving play a vital role in the education of every learner. Now, let us define problem solving according to some mathematicians. Now, according to Stephen Krulik and Jess Rudnick, a problem solving is a situation, quantitative or otherwise, that confronts an individual or group of individuals that requires resolution and for which the individual sees no apparent or obvious means or path to obtaining a solution. And problem solving is the means by which an individual uses previous acquired knowledge, skills, and understanding to satisfy the demands of an unfamiliar situation. The student must synthesize what he or she has learned and apply it to a new and different situation. That's according to Stephen Krulik and Jess Rudnick. Now, according to Henderson and Pingree, in problem solving, there must be a goal, a blocking of that goal for the individual, and acceptance of that goal by individual. Now, according to the National Council of Teachers in Mathematics 2000, page 52, problem solving means engaging in a task for which the situation method is not known in advance. In order to find a solution, students must draw on their knowledge, and through this process, they will often develop new mathematical understandings. Solving problem is not only a goal of knowing mathematics, but also a major means of doing so. That's according to the National Council of Teachers in Mathematics 2000, page 52. Now, all of these definitions of problem solving may be summarized and presented through the following diagram. We have the goal, the obstacle, and the solution. The diagram shows that problem solving is, of course, a process. Now, the goal states what is to be accomplished, of course. The obstacle presents a real problem that hinders one from easily arriving at the solution. And the solution presents the achievement of the goal after the strategy has been employed. It's now the time to reflect to find out if the problem-solving process has been successful. Now, let us talk about the phases or the steps in problem solving. Let's take up first the phases or the steps proposed by John Dewey. First, according to him, confront the problem. Then next, diagnose or define problem. Third, inventory several solutions. Fourth, conjecture consequences of solutions. And of course, fifth, test consequences. That's according to John Dewey. Stephen Kralik and Jess Rudnick had their own phases or steps in problem solving. First, read. Next, explore. Select a strategy. Solve. And then the last step or phase is review and extend. That's according to Stephen Kralik and Jess Rudnick. Now, how about the steps or phases as introduced by George Polya? According to him, to solve problems, especially in mathematics, you need to follow the following steps. First, understand the problem. Second, devise a plan. Third, carry out the plan. And look back or check whether your solutions are correct. So these are the phases or steps in problem solving according to different mathematicians. But in the Department of Education, we are adapting the steps or phases introduced by George Polya. And now, let us talk about the problem-solving heuristics. What is a heuristic? A heuristic or a heuristic technique is any approach to problem solving that uses a practical method or various shortcuts in order to produce solutions that may not be optimal but are sufficient given a limited time frame or deadline. That is the definition of a heuristic. Now, if we are going to apply it in problem solving, we can call that as problem solving heuristics. Now, these are the techniques on how are you going to solve problems, especially in mathematics. Now, what are the examples or different problem solving heuristics that we commonly use in mathematics? Again, these are just some of the heuristics or techniques and problem solving. Okay, there are many problem solving heuristics, but these are just some of the commonly used techniques or heuristics in problem solving. First, we have making a table or an organized list. Next, drawing a diagram, picture, or model. We have also the guess and check. We have the logical reasoning or elimination. We have acting out or acting it out. Then, we have finding a pattern, working backwards, or simplifying the problem. So these are the problem-solving heuristics, or these are just some of the problem-solving heuristics that we can use in solving problems, especially in mathematics, right? Now, let us try to solve problems using these heuristics. Now, in problem solving, take note that we can use different heuristics. In one problem, we can use 1, 2, or 3 different heuristics for us to be able to solve the problem. It's just easy if you are that familiar with the problem already, especially with the heuristics that you're going to employ or use in problem solving. So, come on, let us have some examples. Let us solve some problems.
Okay, so let us have problem. So the first few lines of the Christmas song, 12 Days of Christmas, says,
On the first day of Christmas, my true love sent to me
a partridge in a pear tree.
On the second day of Christmas, my true love sent to me
Sent me 2 turtle doves.
And a partridge in a pear tree.
pear tree. On the third day of Christmas, my true love sent to me 3 French hens,
2 turtle doves.
And a partridge in a pear tree.
okay, so in all, how many gifts were sent by the true love from the first day to the 12th day of Christmas? Now, this song is quite mathematical, diba? So, it says that on the first day of Christmas, my true love sent to me a partridge. So, one gift. On the second day of Christmas, my true love sent to me 2 turtle doves. That's 2 turtle doves and a partridge. So, mathematically saying, it means there are 3 gifts on the second day. Diba? So, first day, we have 1 gift. Second day, 3 gifts. What are those? 2 turtle doves and a partridge. Then, on the third day, my true love sent to me 3 French hens, 2 turtle doves, and a partridge. Okay, in a pear tree. So, in this case, it generates a pattern. We can solve this using the pattern. Okay, so let's try. On the first day, we have 1 plus. On the second day, we have 2 turtle doves plus a partridge. Then, on the third day, we have 3 French hens, 2 turtle doves, and a partridge. On the fourth day, we have 4 calling birds, 3 French hens, 2 turtle doves, and a partridge. And so, the pattern continues. Okay? Until 12 plus 11 plus 10 plus and so on until 1. Right? So in this case, we can say that there is only 12. Okay, so that's 12 times 1 plus how many 11s? We have 2 11s. So times 2 plus we have 10 times how many? 3, because there will be where 10 will be mentioned 3 times. As for 12 will be mentioned once. Okay, on the 12th day na yon. Then 11 will be mentioned twice because it's on the 11th day and on the 12th day. Okay? So we have to continue. We have 9 times 4 because 9 will be mentioned 4 times. Then we have 8 times 5. Okay, 10 plus. Then 7 times 6. then plus 6 times 7. So the pattern continues. If we can notice, we have 12, 11, 10, 9, 8, 7, 6. We have 5 times, dito naman, we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, and we can observe that this is just the mirror of this. Okay, then plus, we have 4 times 9. Plus, we have 3 times 10. Plus 2 times 11 plus 1 times 12. Okay? So again, as we can observe, parang mirror lang ito nung first 1, 2, 3, 4, 5, 6. Nung first 6. Right? So in this case, we can say that 8 times 5 is just equal to 5 times 8. 8 times 5 is 40. 5 times 8 is also 40. So to cut it short, we can say that this is 2 times 12 times 1 is 12 plus 11 times 2 is 22 plus 10 times 3 is 30 plus 9 times 4 is 36 plus 8 times 5 is 40 plus 7 times 6 is 42. And this is also 42. So we can say that we're just going to multiply all of them or the sum of this by 2. Okay, it's just like adding the product of each of the group. Right? So this means that we have 2 times, we have 22, we have 12 plus 22 plus 30 plus 36 plus 40 plus 42 is equal to 182. Okay, so 2 times 182 is 4, 6, 364. Okay, so again, our answer is 364. So therefore, in all, how many gifts were sent by the true love from the first day to the 12th day of Christmas? So, how many gifts? There are 364 gifts, all in all. So, that's quite expensive, diba? Alright, so next, let's have this problem. Odette went to the mall to shop. She went to a store, spent half of her money, and then 500 more. She went to a second store, spent half of her remaining money, and then 500 more. She then had no money left. How much money did she have to begin with when she went to the first store? Okay, so this is a problem. And we can relate to this problem, especially if we have money, then suddenly we take a look at our wallets, wala nang pera. Okay, it's because we spent all of our money. But actually, this problem can easily be solved using the strategy or technique, which is what we call working backwards. We can easily solve this by working backwards. How? Okay, to solve this problem, of course, we have to understand this first. The first data tells us that she went to a store, spent half of her money. So let's say we have her money is equal to A. Then she spent half of her money. So let's divide it by 2. So half. And then 500 more. So she spent another 500. So that's minus 500. Then she went to a second store, spent again half of her remaining money. So that's divided by 2 again. And then 500 more. So minus 500 again. Then afterwards, she then have no money. Okay, so in this case, how are we going to employ the strategy or the technique, which is what we call working backwards. So how are we going to use this? Working backwards, of course, literally, you're going to work backwards. So instead of finding the data or using the first data, you're going to use the last data and inverse the process. Okay, or invert the process. So in this case, we have 0 from the start, which is your last data. Then, the operation is originally subtraction kasi binawas. Now, if you're going to go back, it means it will be added, diba? So, that's 0 plus 500. Okay, so kung ibabalik natin. Then, after that, we can multiply. We can multiply the result by 2 because it's the inverse of division. Then afterwards, we're going to add again the 500 and multiply the result by 2. And that will be the original money. Okay? Now, in this case, as I've mentioned, in working backwards, we do not use the order of operations. We do not consider the order of operations. Because if we're going to observe the order of operations, then we can have a wrong answer. Right? So, let's try to go back. So, 500 times 2 will be equal to 1,000 plus 500 times 2. Okay. 1,500, that is equal to 1,500. Then multiply it by 2, and that is equal to 3,000. And that is the original money. Okay, so therefore, we have 3,000. Or originally, Odette had 3,000 pesos. Okay, so let's check if this is correct. So originally, we have 3,000. Divide, so she spent half of her money. It will now be equal to 1,500. Then another 500, it will become 1,000. Then she went to a second store, spent half of her money. Half will be 500. Then 500 more, that's 500, and that will be equal to 0. Right? So that's how we solve problems using the strategy or the technique or heuristic, which is what we call working backwards. Alright. Next, we have Balmond sells apples. He sold half his apples plus half an apple last Monday. Then, he sold half his remaining apples plus half an apple last Tuesday. Again, he sold half of his remaining apples plus half an apple on Wednesday. He then sold the remaining 27 apples on Thursday. How many apples did Balmond start with? Okay, so in this case, we can also apply or employ working backwards as our strategy in solving this. So in this case, we have to work backwards. We have on Thursday, we have 27 apples. On Wednesday, it says that he sold half of his remaining apples plus half an apple. So it means 1/2 plus 27 or just 27 and half. And sold half of this will be division. But since we are working backwards, we multiply it by 2. So 27 and a half times 2, that's 27.5 times 2 is equal to 55. Okay, so on Wednesday, Balmond had 55 apples. Now, on Tuesday naman, okay, Tuesday, we have 55 plus 1/2, and that is equal to 55 and a half. Just repeat the process. Then, multiply it again by 2 because half. Okay, half his remaining apples. So, half of this, or inverse of division, or half of this will be multiplied by 2. So, 55.5 times 2 is equal to 111. Okay, then, let's have on Monday. Okay, because the question is how many apples did Balmond start with? So, he started selling his apples last Monday. Okay, so we have 111, same process, plus 1 half is 11 and half. Times 2 is equal to 223. So, on Monday or last Monday, Balmond had 223. So, how many apples did Balmond start with? There were 223 apples. Right? So, that's how we solve this type of problem. So, we have used the strategy or the heuristic, which is what we call working backwards. Okay, next. Let's find the difference when the sum of the first 100 positive odd integers is subtracted from the sum of the first 100 positive even integers. So in this type of problem, we are talking about the first 100 positive odd integers and also the first 100 positive even integers. Now, we are going to find the difference of the sum of this. But take note, we're going to subtract the first 100 or the sum of the first 100 positive odd integers from the sum of the first 100 positive even integers. So, in this case, we can use some patterns or we can observe some patterns here. And also, we can use our prior knowledge about the arithmetic series. Okay, if we are going to observe a pattern, let's use the pattern or finding a pattern as the technique in solving this problem. For even integers, we have 2 plus 4 plus 6 plus 8 plus and so on until the first 100, diba? Until 200. Okay, so plus 200. For the odd naman, we have 1 plus 3 plus 5 plus 7 plus we have until 199. Okay? So, by this pattern, it's easy. Just subtract the odd integers from even integers or first 100 odd integers and even integers. Okay. Just subtract. We can say that we have 1 plus 1 plus 1 plus 1, okay, plus 1. Okay, since there are 100 integers here, it will be resulting to, of course, 100 then. Okay, so the difference will be equal to 100. That's using the observed pattern. What we have found here is the pattern na when we subtract the even or the odd from the even, the answer is equal to 1. And since there are 100 positive integers, of course, if we're going to count them, that will be equal to 100. Okay? But there is another strategy. If you know the formula in finding the arithmetic series. So, for the even, okay, so for the even, let's recall the formula in finding the arithmetic series. Ano yun? We have S sub n is equal to n over 2 times a sub 1 plus the n term or the last term, which is a sub n. Okay? So, what's the value of n here? Of course, 100 because there are 100 positive even integers. So S sub 100 is equal to 100 over 2 times the first term is equal to, the first term for the even is 2 plus the nth term, the last term is equal to 200. Okay, so we have this 50 times 202 and that is equal to 10,100. Okay, so that's the sum of the first 100 positive even integers. Now, let's find the sum of the first 100 positive even or odd integers. So, let's have odd. So, S sub n again is equal to n over 2 times a sub 1 plus a sub n. Okay, so S sub 100 din tayo. So, that's 100 over 2. Why 100? Because first 100 positive odd integers. So, times the first term is, of course, it's odd. The first term is 1. Okay, plus 199. Okay. So, in this case, we have 50 times 200. So, we have 10,000. Okay, so therefore, we have this data. We have to subtract the first or the sum of the first 100 positive integers from the sum of the first positive even integers. So, we have even, we have 10,100 minus 10,000. And that is equal to 100. It's just the same with the answer that we have got from the pattern that we have generated. Okay, so let's have the next problem. So let's find two whole numbers whose product is 1 million. Neither of the two numbers has any zeros in it. So actually, we are simply looking for a pair of factors here of 1 million. So each of which does not contain a digit 0. And 1 million is quite a big number, but we can start with smaller numbers. Let's find a pattern, develop a rule, then apply the rule to solve the original number. So we know that we have, let's say we have 10. So the factors of this, if we're going to multiply, avoiding the zeros in it, we have 2 times 5. Okay. Now, if we have 100, we can say that it is 4 times 25 or 25 times 4 because it's commutative. Right. Now, what if we have 1,000? We can say that it is equal to 8 times 125. So, 8 times 125 is equal to 1,000. Okay? Now, what if we have 10,000? Okay? We have, we can say that it's 16 times 625. And that is equal to 10,000. So, by this, we can observe a pattern. So, 2 times 2 will be 4, times 2 will be 8, times 2 will be 16. Okay, then times 5 times 5. So, that's the pattern. Observe that in the numbers at the left, the powers of 10 or the number of zeros after 1 corresponds to the exponents of their factors, which bases are 2 and 5. For example, in 10, there is only 1 zero after 1. So, the exponent of 2 is 1. Okay? And also, the exponent of 5 is also 1. In 100 naman, there are 2 zeros. After 1, there are 2 zeros. And the exponent of each of 2 and 5 is also 2. Diba? So, ganun yung na-observe natin. Therefore, since there are 6 zeros in 1 million, then, yung factors niya, which do not contain any zeros, can be equal to 64 and 15,625. Okay? So, saan siya galing? From 2 raised to 6 times 5 raised to 6. That is equal to 2 raised to 6 is equal to 64. And 5 raised to 6 is equal to 15,625. So we solve this, of course, using the pattern that we have observed. Okay, so let's have the next problem. So Vale served yogurt in his party. Guests may choose one of 3 flavors. Then they may select one of the 4 toppings. How many 1 flavor, 1 topping combinations are possible? So it's just very easy. This is just a very easy problem. If you know about problems involving combinations, ang dali lang nito. Okay, but if you don't know, you can start with finding a pattern or using the fundamental counting principle. Okay, so in that principle, we can say that how many flavors do we have? There are 3. So let's say we have flavor 1, flavor 2, and flavor 3. And how many toppings do we have? So in each of the flavor of the yogurt, you can choose from any of the 4 toppings. Okay, so we have topping 1, topping 2, topping 3, and topping 4. If you have chosen flavor number 2, you can still choose either of the 4 toppings. So, topping 1, topping 2, topping 3, and topping 4. And for flavor 3, it's just the same. So, topping 1, topping 2, topping 3, and topping 4. So, just count the number of combinations. We have flavor 1 and topping 1, flavor 1 and topping 2, flavor 1 and topping 3, flavor 1 and topping 4. So, we have 4. It's also flavor 1 for the next, flavor 2, topping 1, flavor 2, topping 2, flavor 2, topping 3, flavor 2, topping 4. Also with flavor 3. So, how many combinations are possible? There will be equal to 12 possible combinations. So, 1 flavor, 1 topping combinations. There are 12 combinations possible. Okay, but again, it's just a very easy problem. We're just going to multiply these 3 flavors by the 4 toppings. And that is equal to 12. So, 3 times 4 is also equal to 12. So, there will be 12 combinations. Right? So, again, it's just very easy if you are that familiar with this type of problem. So, ang sikreto naman kasi in problem solving is it will not be a non-routine problem na sa'yo, yung problem na yan, if you are very familiar or get used with the problem. You have encountered it many times and you have solved them many times. Okay? Yun ang sikreto in problem solving, especially in mathematics. The more the more that you encounter those problems, it becomes easier and easier for you to solve it. Okay? Next. Fanny has 1,850 in 20, 50, and 100 bills. If she has twice as many 100 bills as 20 bills and 5 more 50 peso bills than 100 peso bills, how many of each bill does she have? Okay, now what do we know here? First, let's list. Yung kanina, we did not actually list the given in what is asked because they're just very easy problems. But do not worry because this is just part 1 of our discussion. Siyempre, sa part 1, patikim lang muna, light problems muna meron tayo. But on the next stream that we are going to have in our next discussion, we're going to level up. Okay? Because we are going to discuss this further until math investigation and math modeling. Right? So, but for now, pagtiyagaan muna natin ang these types of problems. Okay? I know some of you are very familiar with this already. Alam na ito. But then again, this will serve as a review. And for those who are just starting to love problem solving in mathematics, then it's a good start, 'di ba? Para hindi ka masyadong mabigla in our topics. Okay. Now, let's try to solve this type of problem. Okay, what do we know here nga? Jelma has 1,850 pesos in 20, 50, and 100 peso bills. Okay. Now, she has twice as many. Okay, twice as many 100 peso bill as the 20 peso bills. And 5 more 50 bills than 100 peso bills. Okay? Now, what do we want to know dito? Ano bang gusto nating mahanap or makuha as the answer? We have to find the number of each kind of bill she has. Okay, so parang ano ba ang pera na composed nito na 1,850 pesos. Okay, ilan bang 20s, ilan bang 50s, ilan bang 100 peso bills. Yun ang pinaka goal natin to solve this problem. Okay, we can use this by guess and check or trial and error, pwede. But in this heuristic or strategy or technique, you have to be wise, 'di ba, in trying some of the answers. Kasi pag hindi ka wise sa pagpili dito, ang tagal ng answer mo. You cannot solve this in a fast manner. Kaya, you have to think of a way na mas magiging madali ang pag-guess mo. Okay, so let's have a guess first. Let's say we have, so 20 peso bills, let's have maybe 4. Okay, sa 50 peso bills ngayon, mga 15, kasi that's 1,850. Medyo malaki-laki. Then 100, let's say ngayon we have 8. Okay? So 8 tayo. If we're going to say that there are 20 peso bills, we have 80, di ba? So that's 80. Pagka 50 times 15 naman, 50 pesos times 15 pieces, we have 750. Okay. And we have 100 times 8 is of course 800. So we have 0. So that's 13. We have 1,630. And it's not equal to 1,850. So that's our first trial. First guess natin. Now, since alam natin that it's only 1,630 yung unang guess natin, so mag-a-adjust tayo rito na mas malaki-laki. So, let's say we have, for the 20, tasan natin ng konti, we have 5. Then, for 50 ngayon, we have still 15 something. So, this is equal to 100. Estimate lang natin ha. So, this is still 750. So, ilan pa ang kulang para mag-850? 1,850, diba? It's 1,000. Okay, sige. Ito na. 100 times 10. And that is equal to 1,000. So, pag inad natin sila, it will be equal to 1,850. Okay? So, the sum is equal to 1,850. Pero, this is not what we are looking for here. Diba? Ang tanong kasi, how many of each bill does she have? So, how many? Our answer is, ilang 20 peso bills? We have 5. Ilang 50 peso bills? We have 15. Ilang 100 peso bills? We have 100. So, ito yung denomination of the money of Fanny. Okay? Which is equivalent or equal to 1,850. So, that was about the solutions to this problem. Okay? Now, let's try to have another one. Okay, during the birthday party of Sky, the caterer uses 40 small square tables to make a long rectangular table. Now, if each small table can seat only one person in a side, how many people can be seated at the long table? So, it's just a very easy problem again. It's just as easy as drawing them, then finding a pattern, then you can generate a rule out of the pattern. So let's try, we have one table. How many persons? 4, diba? So one table, there are 4 persons. If there are 2 tables, we have 2, 3, 4, 5, and 6. So we have 2 tables, we have 6 persons. So in this case, let's continue para mabuo natin yung pattern. So, we have 1, 2, 3, 4, 5, 6, 7, 8. So, if we have 3 persons, 3 tables, there are 8 persons who can sit there based from the conditions here. So, ito pa lang, we can generate actually a rule or a pattern. Ano yung pattern natin? We have 4, 6, 8. So, we have a common difference. Parang may common na ina-add sa kanila so that we can get the next term. We can actually guess that the next term is equal to 10 because it's plus 2. Plus 2 lang. So 4 plus 2 is 6, 6 plus 2 is 8, and so on. So in this case, it tells us about the arithmetic sequence. Okay? Arithmetic sequence because we are dealing with common difference, okay, which is D. Okay, but actually, if some of you have forgotten their lessons in grade 10 mathematics, you cannot recall the formula anymore. Okay, in this case, let us generate a rule. Okay, take note ito ha. It is my own investigation, based from my own investigation, that in this case, we can actually generate a rule or parang formula so that we can solve this type of problem. So, paano yon? Okay, listen carefully. Diba? 4 plus 2, 6 plus 2. So, ang common difference is equal to 2. So, easy lang. Sa arithmetic sequence lang to applicable ha. So, that's just 2. Get the common difference, then multiply it by n. Ganun lang. Then, you're going to think of a number that will be added to 2 so that we can get the first term, which is 4. So, what are we going to add sa 2 so that we can have 4? Diba 2? So, plus 2. Because 2 plus 2 is equal to 4. Okay? So, therefore, this is now the rule that we're going to use to solve this problem. Okay? So, again, it depends upon the problem. Iba-iba naman. Depende sa arithmetic sequence. So, let's check if this is correct. So, first term, diba? One person, n is equal to the person, or the table pala, table. So, 2 times 1 is 2, plus 2 is equal to 4. If there are 2 tables na, we have 2 times 2 is 4, plus 2 is equal to 6. Then, if there are 3 tables, 2 times 3, 6 plus 2 is 8. Okay? Correct. So, therefore, this rule na na-generate natin is actually correct. Okay? Now, we are looking for the number of persons that can be seated at the long table, having 40 small square tables. Okay? So, if in this case, n will be equal to 40. So, 2 times 40 plus 2. 2 times 40 is 80 plus 2, and that is equal to 82. Therefore, there are 82 people, okay, who can be seated at the long table, having 40 small square tables. Okay na? So, this is how we solve this type of problem. Okay. So, again, it's just very easy for us if we are talking about problems, especially in mathematics. It's easy for us to solve this type of problems if we already encounter it. And sabi nga, practice makes perfect. So, practice and practice, solve kayo ng problems, especially in mathematics, so that it will be easy for you to solve problems, especially in mathematics. Okay, so take note of the problem-solving heuristics that we have discussed for today. Again, these are just some of the easy problems that we may encounter, but it may evolve into a more difficult problems. But again, if you know the technique or the right technique or strategy that you are going to use, then it's just an easy problem next time when you encounter this. Okay? So I hope you have learned something from this lesson.
That was about the problem solving and problem solving heuristics. Next time, we will be discussing more about problem solving heuristics. So that's all. Thank you and see you in our next lesson.